Hi everyone, so it's Ms. Martins, and as promised, I'm going to give you guys a quick video to finish out lesson 1.7. Some of this is going to be review, some of it's new, but because of what we did in class, hopefully this is pretty understandable even from home. So have your notes out that I gave you in class and fill in as we go, and feel free to rewatch anything if you need to hear something a second time. So, as we said in class, a circle is the set of all points in a plane at a given distance from a given point. Okay, we talked about the word equidistant, so again, it's equidistant from a given point. That given distance is called the radius, and the given point is called the center. So, in other words, it's the radius distance away from the center, each point along the edge. You name a circle by its center. The circle on the bicycle wheel with center O is called circle O. When you see a dot at the center of a circle, you can assume that it represents the center point. So this is one of those unusual times where you're allowed to assume, and when you see a when you see a dot that looks like it's the center, it probably is the center. So continuing on, a segment from the center to a point on the edge of the circle would be called a radius. Its length is also called the radius. A bicycle wheel is a physical model of a circle, and one spoke is a closed physical model of a radius. So in your head, think of a circle as the bicycle wheel, think of the spoke as the radius. Okay, continuing on. Okay, this is a cute little comic, so feel free to pause and read this or continue on with me. So, what is a chord? We talked about this in class. You've got examples on the left, you've got non-examples on the right. So, a chord, as we discussed, is a segment whose endpoints lie on the circle. Okay, it has to be a segment, it can't be a line, can't be an arc, can't be anything other than a segment. It's allowed to go through the center, doesn't have to. Okay, all the examples on the right are not chords, so PQ is not a chord because Q is not on the circle itself. RS is not a chord because R is not on the circle. Okay, and then on the right hand side, all the way to the right, we've got T and U, which are points, so they're not chords. Okay, we've got VW not representing a chord because it's a line and it doesn't have two endpoints on the circle. It fails at for multiple reasons. So what I would recommend in that chart, on the left-hand side, you're going to write a definition in words, and on the right-hand side, you're going to do a picture model. So you can pick any example from the left-hand side to just do a quick sketch of what a chord looks like. So we're going to have three definitions here. The first row is for chords, and then we're going to continue on to the second row next. Okay, so the next row, we're going to define a diameter. So in the second row, the definition on the left-hand side would look something like this. You've got, it's a segment whose endpoints are on the circle, and it goes through the center. Okay, on the right-hand side, we can see a bunch of non-examples. RS doesn't go through the center. PQ is a radius, its endpoints are not on the circle itself. Same with WV, the endpoints are not on the circle itself. TU is a line, okay, and that line does not go through the center. So all of those are non-examples of a diameter. So now in the second row of your chart, you're going to define it in words and you're going to draw a picture example. Any of the examples will do. Okay, continuing on. In the third row of your chart, we're going to put the word tangent. Okay, we're going to define a tangent as a line that intersects a circle at exactly one point. Okay, so that's the word definition. For the picture example, you can put any of the examples on the left, totally okay. Just remember it kind of skims the surface of the circle. That's kind of the way I visualize it. So on the right-hand side, you can see a bunch of things that aren't tangents. PQ is not a tangent because it crosses at 2 points. WV is not a tangent because it's a ray, it's not a line. TU is not a tangent because it's a segment, not a line. SR is not a tangent because it looks like it's not touching the circle at all. Okay, so take a note at the bottom. You can see that line AB is a tangent, or you can say line AB is tangent to circle O. The point where the tangent touches the circle is called the point of tangency. So this should all be reviewed from class. Continuing on. Okay, this is not in your notes, so feel free to just put that aside for a second and just think. Okay, so can a chord of a circle also be a diameter of the circle? Can it be a tangent? Okay, think about why or why not. So pause the video for a moment and then resume when you're ready to hear the answer. So tackling the first part of the question, can a chord of a circle also be a diameter? We discussed this in class, and yes, a chord can be a diameter as long as the chord goes through the center. So yes, that is possible. When we scoot over to the second question, can it be a tangent? That's a little trickier because remember, a chord is a segment and a tangent is a line. Okay, a chord crosses the circle at 2 points, a tangent only crosses at 1 point, so there's no possibility for overlap there. So question 1 is okay, question 2 is no, absolutely not. Continuing on, here's thinker question number 2. Again, you don't have to write it down. Can two circles be tangent to the same line at the same point? Draw a sketch and explain. Again, pause the video, and when you're ready, resume it. So the answer would look a little something like this. Okay, yes, two circles can be tangent. They could be externally tangent, where the two circles are kind of side by side, or you could think of them as internally tangent, and that's where the two circles overlap but touch at one single point. Continuing on. Okay, back to your notes. So if you put those aside, make sure you grab them back. If two or more circles have the same radius, they're congruent circles. If two or more coplanar circles share the same center, they're concentric circles. All the CDs represent congruent circles, but if you look closely at each CD, you can also see concentric circles within each CD. So the way I remember concentric is I think of Spanish, con means with, and you can see the word center hidden in centric. So I think of concentric circles as with the same center. Okay, continuing on. An arc of a circle is 2 points on a circle and a continuous or unbroken part of the circle between those 2 points. The 2 points are called the endpoints of the arc. So you have a space at the bottom of your notes for a sketch. Just sketch a little curve that looks like what you see on the right-hand side, and the endpoint should be A and B. Okay? So think of an arc as a piece of a circle. So continuing on to the back of your notes, you're going to see it starts with arcs have a degree measure. Unfortunately, that's a typo. So we're going to skip down to the second paragraph, which starts with you write arc AB. Okay, so second paragraph starts next. You write arc AB as AB with an arc sign over it, or BA with an arc sign over it. Okay, so notice that those signs are missing from your notes. Please add them in. So it's almost like the hat of the line segment, but it's got a little bend in it. So arc AB, that first one, doesn't have a symbol because it's got the word arc in front of it. But if you head next to it, there's another AB that doesn't have the word arc in front of it. That should have the little curved hat, and BA should also have the curved hat. Continuing on. You classify arcs into 3 types: semicircles, minor arcs, and major arcs. A semicircle is an arc of a circle whose endpoints are the endpoints of a diameter. Okay, in other words, a semicircle is half of a circle. Okay, you can think of like semi-sweet chocolate chips. Semi means halfway. It's not quite sweet, it's not quite bitter, it's semi-sweet. Just like semicircle is half of a circle. A minor arc is an arc of a circle that's smaller than the semicircle. A major arc is an arc of a circle that's larger than a semicircle. Okay, so minor means small, major means big, so you can think of it in relation to that semicircle or that half circle. You can name minor arcs with the letters of the 2 endpoints. So in this way, it's very similar to segments. We name them by the endpoints for a segment. We name arcs by the endpoints of the minor arcs. However, for semicircles and major arcs, you need 3 points to make clear which arc you mean. The first and last letters are the endpoints, and the middle letter is any other point on the arc. So take a look down below. You've got minor arc PD. Since minor arc is smaller than a semicircle, okay, you only need 2 points, the endpoints, to name it. However, look at semicircle APD. That starts at A, goes through P, and all the way on to D. This one is a semicircle, and it requires 3 points. And the reason is if we just named it AD, we wouldn't know whether we're talking about the top half or the bottom half. So it's really important to include a middle point so that way we know which way to go. Okay, same thing over here, major arc PAD. If you didn't put the A here, PAD, we might think you were talking about the minor arc PD. right? So it's really important to distinguish whether you're dealing with minor or major arcs using the number of letters, and that will kind of tell you which path to follow around the circle. Okay, so take a moment and try to name another minor arc and another major arc in this diagram. Okay, and pause the video and come back when you're ready. So another minor arc would be arc PA. Another major arc might be PDA. Okay? So why are there 3 letters needed to name a major arc? It's to distinguish it from the other piece of the circle, its corresponding minor arc. Okay? Continuing on, should be the last paragraph now. Okay? Arc measures. Okay? Arcs have a degree measure just as angles do. A full circle has an arc measure of 360 degrees. A semicircle has an arc measure of 180 degrees, and so on. The arc measure of a minor arc is the same as the measure of the central angle. The angle with its vertex at the center of the circle, and sides passing through the endpoints of the arc. The measure of a major arc is the same as the reflex measure of the central angle. So this is the nice piece. Here we have angle B. The center is not labeled, so we'll call this BOC. Let's let O be the center, okay? This measures 45 degrees. So that means that this arc out here measures 45 degrees as well, okay? Then we have the reflex angle over here, which is 360 minus 45, and that's 315, okay? And that means that arc BDC in green also measures 315. So it's really nice. It's basically just saying what proportion of the circle is this arc, okay? And we use degrees to reflect that proportional relationship, okay? So at this point, we're done with notes. Thank you so much for listening, and I hope you have a great rest of your night.